Welcome to classes on physics, higher secondary year, and today's class is the last part of atoms. And it is a very important class only because of the facts that today I am going to do a lots of solutions or the problems of lot of questions which appeared in IIT, IEEE, PMT, CBSE, PMT, JEE, JEE means and EET, etc. So you minutely follow the class, and I hope you will get a lot of things and lot of information from this class. And don't be afraid, be patient while you watch my class, and surely you will gather a lots of knowledge regarding the last part of the chapter, atoms, in physics higher second year. So before starting the class, let me do some of the key points. I am giving you some of the key points or formulae upon which I am going to solve each and every competitive exams questions on the spot. So these are the some important formulae I have just written for a solution of the problems. You need to know these formulas, and you should please try to keep it in your mind by learning by heart or by any means. And these formulas are very simple, and some of the formulas I will establish here on spot on board. So kinetic energy equal to Z square by twice R potential energy minus kz square by R. Kinetic energy is equal to minus total energy, or total energy equal to minus kinetic energy, twice kinetic energy equal to potential energy. Energy, this is equal to energy is equal to 4 pi square km square z square by z square e to the power 4 divided by n square e square. R radius is equal to r, n is equal to n square a square by twice pi square kz square m, and twice the sin theta is equal to n theta. This is Bragg's law. And there is a question upon this one. Crystal lattice related question is there. I will explain it a bit later on. Energy is equal to h nu equal to hc by lambda is equal to hc by lambda. Hc 1 by lambda is equal to nu bar is equal to wave number. Am I right? Here 1 by lambda is equal to nu bar. So E equal to h nu equal to hc by lambda is equal to hc 1 by lambda is equal to nu bar is equal to wave number. So 1 by lambda, or this is you can write wave number is equal to 1 by lambda is equal to r is equal to 1 by n square 1 by n2 square, where the value of r is known to you. R is equal to, it is a constant, Rishbach constant. It is very often it is known to you, and this is this 1 by lambda is equal to r into 1 by n square minus 1 by n2 square. I will discuss it a bit later on, and you will find it again. An impact parameter also I have also already mentioned in the last class. Z square by cos theta by 2 is equal to 4 pi e naught by m square by r, or you can write kinetic energy closest approach r not equal to 4 pi z square by kinetic energy and number of the spectral lines n minus 1 by 2 tn is equal to 1 t 1 by n cube, that is the time period. Rn is equal to 0.053 Bose radius into z square by n square, atomic number of principal quantum number. And these are the simple formulae you should learn before starting the question. So I will start with the question, today's chapter on energy, and I will not establish the relation of energy. And in the last class I have already established the formula, the relations of radius square by twice pi square z square z e square by z square. I have already established it. So this is a very simple relation. You can establish yourself. This is the formula. Energy of electron rotating in the various orbit is, you can establish yourself from any book, you can find it. So I don't find it necessary here to establish this one and to kill time in this way. Energy is equal to 4 chi square m k z square z square e to the 4 by n square a square. Everything you know. 4 is no, pi value is no, mass of the electron is no, k value of k into 9 into 10 to the power 9 you know. Charge of electron is known to you. Principal quantum number, that is orbit 1, 2, 3, it is known to you. H equal to Planck constant is equal to 6.62 into 10 to the minus 34 joule. Everything you know. Okay. So you know this one. Just one thing, just here, a simple question very often asked in entrance exam or class exam, why there is a negative charge. Negative charge in energy means there is Coulombic attraction towards the nucleus. That is, electrons are bound towards the nucleus due to the Coulombic attraction forces, and that's why the negative sign appears. And also some amount of energy is required to pull out the electron from the orbit. Am I right? This is why the minus sign appears in the energy. But there is a tricky question very often asked in the any type of entrance exams, in IIT exams, IIT exams, always a question comes on energy. So before starting the solving the questions answer, let me tell something about potential energy and kinetic energy and total energy. That's I have shown you that kinetic energy is equal to minus total energy, or total energy equal to minus kinetic energy, or potential energy twice kinetic energy. How can you keep it in your mind where from it has come? I will show you. And what are the relation if the electron is excited to the higher orbit, or if electrons come back to the lower energy level by losing out or emitting out the electron energy, what will be the state of the kinetic energy and potential energy, and what will be the variation of total energy? I will explain, because this part of the question is very often asked in the competitive exam. So before starting this one, let me explain one thing. Everybody of you know, if you throw a stone upward with a big force, so you will find that after some time it will come back on the ground. So while you have thrown the stone upward, the kinetic energy with at the very this stage while starting, when you have thrown out from your hand, the kinetic energy is maximum, and after some time the speed or velocity of the stone with which the force you have applied will reduce. Am I right? A time will come, at certain point the stone stops, and from this stopping point it starts coming back to the ground. So what's happened at the greatest height, at the middle of this kinetic energy gone increasing, and sometimes at the top of this level the kinetic energy becomes zero and start moving downwards. Means when kinetic energy increasing, potential energy is decreasing. Potential energy is due to position. Am I right? So at the point of height, when the kinetic energy becomes zero, at that point potential energy is the highest. Total energy remains conserved. And when it starts falling, kinetic energy decreases, potential energy increases. During the fall of this one, before starting, again after some times, when the earth attract the stone towards itself, that's why it is coming returning back to the ground. Am I right? The kinetic energy again starts increasing and potential energy decreasing, because at the highest point when the H is more, potential energy more. H reducing means potential energy is decreasing, and the attraction towards the nuclear, towards the gravity attraction of gravity increases, kinetic energy increasing. At the final stage, when stops and touch the ground, kinetic energy and potential both decreases, both becomes zero. Am I right? This is the fact. Means when electron is in the highest energy level, electron is excited. During the excitation of electron, what happens? From this level to this level, from this level to this level, from this level to this level, this level to this level, that electron has gone out. This on excitation means when you have applied some amount of energy, electron absorbs energy, and with this absorbed energy starts jumping to the higher energy level. Am I right? So what's happened? As you move further and further, what's happened? What if I tell you, when the electron is excited to the higher energy level, there is two conditions. One is when electron is excited to the higher energy level, again electron comes back by releasing this amount of energy. Am I right? So first is when electron is excited from lower energy level to higher energy level, what is the variation of kinetic energy, potential energy and total energy. So what is kinetic energy? Kinetic energy is equal to kz square by twice r. Am I right? Kz square by twice r. So as electron is excited from lower level to the higher and higher and higher level, then radius increases. Radius increases means denominator is increasing, means kinetic energy is increasing. So when electron is exciting from the lower energy level to higher energy level, then kinetic energy is decreasing since radius increasing. So kinetic energy, if increases, kinetic energy, potential energy twice of kinetic energy, or you can give it here mass. So what's happened? As the distance increases, height increases, h increases, potential energy will increase. Now, when electron starts coming back, as it approaches towards the nucleus, what's happened? The radius by degrees is reducing. So when it is coming to the ground state, energy level 1 from the higher energy level, then radius decreasing. So when radius is decreasing, means denominator is decreasing, means kinetic energy is increasing. So whenever you are asked on excitation from lower level to higher energy level, kinetic energy will decrease. On coming back of electron from higher energy level to the lower energy level, radius decreases, kinetic energy increases. Am I right? So this is the leading idea with the help of which we will explain one or two of question asked in IIT or IEEE or in higher exam. Now where from we got this relation? Kinetic energy equal to minus of total kinetic energy. Kinetic energy is equal to minus of total energy. Total energy equal to minus of kinetic energy. What? Potential energy twice of kinetic energy. How will you get? And very often question asks from these two. Some amount of kinetic energy is given. You are asked find potential energy. You are asked find kinetic energy. You are asked find total energy. So you need to know the formula where from it has come. What is kinetic energy? Kinetic energy is equal to kz square by twice r, and potential energy is equal to minus kz square by r. Am I right? So what is total energy? Total energy is equal to kinetic energy plus potential energy. What is kinetic energy? Kz square by twice r minus kz square by r. So what we get here is we are getting this result. So now what's happened? You can do one thing. So you see this is minus kz square by twice r. So kz square by twice r is equal to kinetic energy. So you are getting minus kinetic energy. That is total energy is equal to minus kinetic energy, or kinetic energy is equal to minus total energy. This is the formula I have established. This is how the total energy is equal to minus kinetic energy. Keep it in your mind. Very often question asks. Now second point is that kinetic energy is equal to z square by twice r is equal to minus half out minus z square by r. Can I not write in this way? Yes. Kinetic energy equal to z square by twice r. I can write it minus half half taken out and minus inside z square by r. Again z square by r minus k z square by r is equal to potential energy. This is equal to minus potential energy. Therefore potential energy, you can take minus or not minus, potential energy is equal to twice kinetic energy. This is another relation, that potential energy is equal to twice kinetic energy. These 2 points, that kinetic energy is equal to total energy minus total energy and potential energy equal to twice of kinetic energy. This is very important. That is the way I have derived it for your clear understanding. Option, lots of options were given and you are asked which of the following options are correct. When an electron makes a transition from excited state to the ground state, means higher level to the lower level, ground state, it makes transition after losing energy. So what is the position, what is the state of kinetic energy, potential energy, total energy? So at the very beginning I told you, when it starts coming back from high energy level to the lower energy level, radius gets reduced, radius becomes slower and slower. So kinetic energy equal to k z square by twice r. If radius becomes smaller and smaller, means kinetic energy will increase. First of all, kinetic energy will increase. So with kinetic energy, so this relation there is minus, am I right? In my a discussion a bit earlier, I have discussed on kinetic energy twice potential energy, kinetic energy equal to twice potential energy, there is a minus. So if kinetic energy increases, then potential energy will increase negative, that will decrease with negative value, with greater negative value. So now what is total energy? Now what is the state of total energy? Total energy is equal to minus kinetic energy. Am I right? If kinetic energy is increasing, total energy is equal to minus kinetic energy. So if kinetic energy increases, you put this increased values here. So total energy also will decrease with greater and greater negative sign. So total energy will decrease. Am I right? This is the question asked in IIT. Very simple, not tough. It requires your concept and simple understanding, nothing a hot type of question. Was limitation of Bohr's theory. In my last class, I talk about Bohr's theory of hydrogen atom. Now, what is its limitation? Number one, again there is a question. Often question comes from this limitation, not directly, but in indirect question. In IIT, there is a question. I will tell you a bit later. Number one, first of all, it explains only single electron system, that is hydrogen atom. Spectra, it can explain the spectra. A bit later I am coming spectra. It can explain the spectra of single electron system, that is hydrogen atom. It cannot explain multiple spectra of multiple electron system. Lithium, sodium, magnesium, multiple electron system spectra cannot be explained by Bohr. It can only explain the spectra of single electron system, but cannot explain the spectra of multi-electron system. A question comes in IIT in 2002. I think the question was like, when neon is monohydric, which one of the following phenomena cannot be explained by Bohr's theory? In the option, there was each and every three options were single electron system: deuterium, proton, hydrogen, like this. Helium 2 negative, all are single electron system. But one is mono, the first excitation states of neon, 10 electron system. And that was the correct answer. That is neon spectra. In neon cannot be explained by Bohr's theory as the system is not single electron system. Am I right? So first limitation is there. Second limitation, it cannot explain Zeeman effect. Zeeman effect so also cannot explain Stark effect. Stark effect. I am explaining verbally what is Zeeman and Stark effect. Means spectral lines further splits in presence of magnetic field was observed by Zeeman, and why there is further splitting of spectral lines in presence of magnetic field is called Zeeman effect, cannot be explained by Bohr. And Stark effect, again the spectral lines further splits in presence of electric field, and this effect was shown by Stark. Hence, why there is further splitting of the spectral line in presence of electric field is called Stark effect. This Zeeman effect and Stark effect could not be explained by Bohr. And third one is again very simple. He chose circular path for electron to revolve, but why not? Why not? Why not elliptical? Elliptical orbit, which is also possibility of electron to move in an elliptical orbit. These are the sum of the limitation. This limitation, please go through deeply through this. For exam point of view of class, it is important, but you may skip this while you appear make preparation for higher entrance exam. But very often from this very simple questions, a question is made in the higher entrance like IIT or IIEEE. Spectral lines or spectral series in hydrogen atom and mono electron system, single electron system, there is spectral lines. Now what is spectral lines and how does it occur? Spectral lines, actually when hydrogen atom is excited or when energy is supplied to it, in the excited state of the hydrogen, single electron does what? It jumps from lower energy level to higher, higher to higher, higher to higher. And after some time, it starts losing the amount of energy it has already absorbed and starts coming back to its initial position. So while it loses electron, according to the Bohr postulate, we see what? Del is equal to h nu is equal to hc by lambda. So there is release of energy, means change of energy from any to a energy level E1, E2, E2, E3, E4, E5 energy level. There is change of energy. This change of energy, according to from both postulate, we have seen that it is equal to h nu is equal to hc by lambda or equal to hc nu bar. 1 by lambda is equal to nu bar. Means my main method is not to show you the h. Again, you can write equal to hc and 1 by lambda is equal to nu bar, wave number. You need not to show it. Just I am showing up to here. So here we see that energy is related to lambda. When it loses energy, so there is corresponding wavelengths. So due to this process, we see some of the lines during release of energy, lines appears, and these lines are called spectral lines. So there are a lot of spectral lines are visible in the excitation state of hydrogen atoms when it comes back to its ground state, means energy level 1. Due to release of energy, there is a wavelength is related. So UV light, IR light, visible lights, in different regions we see different lines. These lines are spectral lines. So these are in very simple. I am not going in details. These are in a very simple way. What's happened? We have seen that 1 by lambda is equal to r is equal to r into 1 by n1 square, 1 by n2 square. It is Rickenbach constant. We can use this constant and this one. Now, what is n1, n2? I am coming to this place, to this part. So there are some series. First one is Lyman. Lyman series So the series of the line, a lots of I am for time, shortage of time, I am not showing these details. Any books you look at it, and this is n1 is equal to 1, 2, 3, 4, 5, 6. Just I am showing you Lyman series appears here. The spectral lines appears. What's happened when electron falls? N1 is equal to 1. N1 is equal to 1. From which level? From higher level of 1. If it falls from 1, it may fall from 6 to 1. It may fall from 5 to 1, 4 to 1, 3 to 1, 2 to 1. So where from it will fall, except 1 from higher orbit, it can fall, energy level it can fall. That is, if N1 electron, it jumps from this level to 1, N1 is equal to 1, the ground state is equal to 1. So where from it will jump? It will jump from 2, 3, 4, 5, 6. For I have just explained one. Second one, same. Bummer, you should keep it in your mind. For Bummer, N1 is equal to what for person, what N equal for bracket, what is for P-fund, what, and this is very recent. It is not given in your book. What is the ground state? So ground state you should keep it in your mind. And for other, from where is it come? This is from the next of this, next of this, next of this, next of this, like this. So they have got in this way Lyman, Balmer, Parsons, bracket, Buffon, and Humphrey. Am I right? So these are the series, different series. So if it is Lyman, so n1 is equal to 1, 1 square, and n2 is equal to maybe 2, maybe 3, maybe 4. So likewise for Balmer, n1 is equal to 2, for Parsons, n1 is equal to 3, for bracket, n1 is equal to 4, P-fund, n1 is equal to 5, Humphrey, n1 is equal to 6, and above this n2. So there is infinity up to this one. So this is a very important formula. With from this formula, lot of questions are asked, and I am bit by bit proceeding so that you can understand. Just keep it in your mind with your simple understanding. So here I am explaining this one, keeping in view of this some of the question. A question once comes in IIT, the neon sign. In the advertisement, neon board in the street light, you have seen neon. So the if in neon sign, what type of emission spectra comes out? Spectra, absorption spectra, emission spectra. It is a bit another things. I am not going to this. In neon sign, what type of emission spectra is possible? Neon is atom. Am I right? So this is atom means line spectra. Here from it is line spectra. If there is molecule, from the molecule if you get a spectra, molecular spectra, and this will give you band spectra. And if you black body radiation is there, from black body radiation type of spectra is the continuous spectra. Am I right? So just for your understanding that a question appears in IIT, that's why asked in IIT, that's why I am telling you black body radiation gives you continuous spectra, molecule from this spectra arrived from the molecule is this appear from molecule is called band spectra, and atomic spectra, the spectra which comes from the atoms are called line spectra. So the answer is line spectra. So one of the important tricky question very often asked in the entrance exams, and very often in maximum entrance exam you will find out what are the number of the spectra appears if the electron jumps from n is equal to 2, n is equal to 3. Say a question n is equal to 4, and electrons if electron jumps from n is equal to 4 excited states to the ground state, what will be the number of the spectral line appears? So 1, 2, 3, 4. Say energy gap is a bit high here. I have shown you. So you see, this is 4, this is n is equal to 4, this is 3, and this is 2, and this is 1. Am I not? Am I not? What is the simple way of calculation? So from n is equal to 2, it is one line. So how much line you have got? You have got 1, 2, 3, 4, 5, 6. So sometimes when n is equal to 6, 7, 8, you may lose time to calculate how many lines will appear in spectral lines will appear from jumping from excitation of electron from n4 to the ground state. Am I right? So simple formula, line of spectral line, number of spectral line appear during the de-excitation of electron to the ground state is equal to n into n minus 1 by 2. Very important formula I have shown written here somewhere. I think I have forgotten to write. Yes, I have number of spectral lines equal to n minus 1 by 2. So now you see n is equal to 4, 4 means 4, 4 here, 4, 4 minus 1 is equal to 1 is equal to 2. So 4 into 3, you are getting 6. So what I done practically is this, and what I did from the formula is also the corresponding values are same. So I think if you apply the formula, with the help of formula, if you solve it, it will save time. So with the help of which you can solve it very easily, and also orally you can do it and can save times in the entrance exam. So already I have written you, if the kinetic energy alpha particle, when you bombarded the gold foil with the alpha particles, you have seen that with the help of which in the last class of class number 3 or 2 I have shown you the closest approach. The closest approach is actually equal to 4k in z e square by kinetic energy. So closest approach means it is a distance. Closest approach is a distance, is proportional to, inversely proportional to the kinetic energy. So you are asked, kinetic energy of alpha particle in gold foil is doubled. Kinetic energy is doubled. So what will be the closest approach? Answer, it will be reduced to half. Kinetic energy is half. If put the double value, yeah, so closest will be half. Simple. Because closest approach is inversely proportional to kinetic energy. If kinetic energy is double, so closest step will be reduced to 1/2 of the initial. Simple, nothing to explain. Or if you want to solve it, so you do this one. This is one initial one, and you do this is final kinetic energy. Am I right? So it is double of initial. Double of initial. Am I right? So R1 and R2, you divide these three, you will get the relation. Nothing to it, is very simple calculation. I need not to show you. You can very often do it yourself. Only you keep it in your mind, closest approach is inversely proportional to the. Again very simple. Again very simple. If in hydrogen atom, In hydrogen atom, if electron is replaced by another particle which is 200 times heavier than that of electron, but charge is the same of the electron. Now what will be the consequence of radius? Simple. What is radius? Radius is equal to, what is radius? Radius is equal to n square a square by 4 pi square no need to write anything, just n square by 4 pi km twice z square. Am I right? Everything is constant, only you see the relation. Radius is inversely proportional to the mass of the electron. So in place of the mass of the electron, if you take 20 times heavier something, so it will be, radius will be 1 by 200 times of the initial radius. If you make it 200 times, so radius is inversely proportional. So 1 by 200 times of initial radius. If you replace the electron with another particle which is 200 times heavier than electron with same charge. I have already written it, impact parameter. For somewhere I have written impact parameter B is equal to Z square by cot theta by 2 is equal to 4 pi epsilon naught mb square by r. Am I right? What you are asked is very simple. You don't be confused and puzzled. When you see the question is very tough, nothing tough is there. If the impact parameter B is equal to 0, what is the scattering angle? Simple. B is equal to Z square cot theta by 2 is equal to 4 pi epsilon naught into mb square by r, or kinetic energy. That is, impact parameter is inversely proportional to the kinetic energy. If kinetic energy is more, impact parameter is less. If kinetic energy is less, impact parameter is more. That is, impact parameter is inversely proportional to 1 by kinetic energy. One relation, sometimes it is asked, if the kinetic energy is increased or make it double, what will be the impact parameter? It will be the half of the initial one. Am I right? So simple. But here the question is a bit twisted. And already I have also already mentioned the implication of impact parameter in finding out a lot of inferences in my first classes. If B is equal to 0, theta is equal to 180, if you keep it in your mind, you can solve it very easily. I have already mentioned, if impact parameter is 0, means it is directing towards the nucleus, alpha particle directing towards the nucleus, the angle will be 180, it will retrace back head and collision of the nucleus, and then the bombarding alpha particle will be there. But mathematically, how will you prove this? If theta is equal to 0, z square by cot theta by 2 is equal to 4 pi epsilon naught kinetic energy. So if this part is equal to 0, then this is equal to 0, then cot theta by 2 z square also into equal to 0, then what you get here? Cot theta by 2 is equal to 0, then cot theta by 2 is equal to cot of 90. Am I right? So this is 0, then theta by 2 is equal to 90, then theta is equal to 180, means there is head-on collision. The bombarding electron alpha particle is back to its initial through the initial line. Means if the impact parameter B is equal to 0, then the scattering angle will be 180, means there is a head-on collision, then electron will bombard, so alpha particle when bombards, and if it face the nucleus head-on in the same line, then it will retrace back, means then theta is equal to 180. This is very simple question, nothing to explain, very simple. Very simple question asked in JEE in 2022. When you talk about JEE, we think about that a question is very tough and this and that these questions are not tough. I will bit by bit coming solution of all JEE, JEE, AIMS and IIT and NEET. Please be with me in the class with patience. So this question, what is moment of the electron in the nth orbital? What is moment of electron there? What is Bohr orbit of quantization of energy? Bohr's orbit theory of quantization of energy, n is equal to h by twice pi. Angular momentum is equal to mvr is equal to n h by twice pi. You are not asked angular momentum, you are asked with momentum to make you confused. Now what is momentum? Is it not momentum? So mvr is equal to n h by twice pi r. Simple. This is the option where we will get these options. You will write the answer. You write from quantization postulates of the Bohr's theory twice MBR is equal to NH by twice pi. So from MBR it is angular momentum. So you just you write VR is equal to momentum is equal to NH by twice pi. Am I right? Nothing to explain. So we have solved out one questions of JEE 2000. So very simple. Downstate energy of hydrogen is equal to, we have already calculated, it is known to us, minus 13.6 electron volt. Now you are asked to find out kinetic energy and potential energy. So this is the total energy. So what is kinetic energy? Kinetic energy is equal to minus of total energy is equal to minus, what is total energy? 13.6 electron volt. So this is equal to, simple. At the very beginning I told you, when you write the relation kinetic energy equal to total energy and total kinetic energy twice of kinetic energy equal to minus potential energy, and these things will come in need in solving the questions answer. And you have already got a question in the exam, entrance exam. It is from CBSE PMT, kinetic energy, total energy. Therefore about kinetic energy this, and what is potential energy? Potential is equal to twice kinetic energy, twice into 13.6, you multiply. It is, I think, maybe like this. Simple. In a second, within fraction of second you can solve it if you have the knowledge of the relation or how it has appeared. Sometimes you may forget, you just write and you evaluate the relation within a fraction of second in the exams, and you can solve out this question from here. Again, very interesting question. You increase your thinking capacity, you can very easily answer. Again, it is from entrance, CBSE PMT. I have taken this example, very interesting, that's why I have taken this one. An atom is in third excitation state. What is the momentum of the spectral line? What is the number of the spectral lines which and which transition means from upper level to lower level, it is coming, high level to lower level, it is coming, there is a transition, loss of energy is the transition occurs, and corresponding to which transition the wavelength will be the minimum or the lowest. Which transition, from which level to which level it moves, the wavelength will be the smallest one, minimum one. You have to ask, you have to find out. Means one thing, if it is in third excitation state, this is the critical aspect of the point. Third excitation state means where is the electron is locating. If it is third excitation state, where electron is locating. If it is N1, 1 level, 2 level, 3 level, means N1 1, N2 2, N2 3, N2 4. If you find out the highest excitation level, then from this level we can very easily calculate the spectral lines. We need to calculate in which energy level the electron is residing. Am I right? So what is excitation state? I am just explaining, just you listen, minutely you follow. Say this is the nucleus, this is the nucleus, this is level N is equal to 1, N is equal to 2, 3, 4. When electron is excited, energy is supplied. So from first level to this level it jumps. So from first excitation, electron is residing N2, N is equal to 2. Now this is fast excitation, this is fast excitation state, this is fast excitation state. Now again, when you supply energy, it jumps from this level to this, it has gone to 3, and this is called second excitation state. Now again, if you supply the energy, then it jumps from this level to this, so it has reached to this level 4, and this is called third excitation state. So means third excitation means electron is residing in 4, N is equal to 4. So N is equal to 4, their spectral line you can calculate it very early. I have given you the formula, or I have shown you the figure as to how you can assume, but I will not go through the formula. I will just apply the formula. This will give you the 6. You put 4 minus 1 equal to 3, 3 to the equal to 6. There will be 6 spectral lines. First question is over. But question is that if you cannot find out third excitation state, if you put N is equal to 3, your answer will be wrong, because third excitation state, first state, second state, third means electron is residing in 4th. So from 4th, first coming back to the down state, 6 spectral lines will appear. Now question, and a tricky question, which transition will correspond to the lowest wavelength? So what's happened? We know the change of energy is equal to H nu is equal to Hc by lambda. Am I right? From change of energy, it loses energy, loses an energy. E1, E3, E4, E4 minus E3. You are getting some amount of energy. This energy is related to C by lambda. That is, E is inversely proportional to lambda. Where energy is the more, wavelength is the less. Where energy is the less, wavelength is the more. You are asked the lowest wavelength. So I am taking one. When it's coming back from N1, N4 to N3, some amount of energy is released. Again, if you assume N4 to N1, 4 to 1, again huge energy. Why is the energy gap is more? Energy gap is 4 to 1 is more. If energy is more, lambda is less. So if the energy is less, lambda is more. So lowest wavelength, next point is correspond to n is equal to 4 to n is equal to 1. Since 4 to 1 makes a big amount of energy, and big amount of energy means less amount of wavelength, that is lowest wavelength is correspond to jumping of electron from n4 to the n1, not 4 to 3 or 4 to 2 or any other corresponding transition. Very interesting and tricky question. I hope you have understood. This question is asked and very often asked such type of questions in any type of the competitive exam, and this was AIPMT not available nowadays. This question exams are not there. AIPMT, CBSE, PMT, this question was asked. Ratio of the longest and shortest wavelength in Lemon series. So what's happened? I told you at the very beginning. So transition occurs in Lemon is equal to, I told you, you keep it in your mind. Lemon, mama, bracket, Papon, like this, you keep it in mind. N1 means electron from higher energy level, from infinity, from higher energy level will fall upon what? This is the main one, level 1. So you are asked the longest and shortest wavelength in Lemon series. Now what is the formula? First of light, 1 by this is equal to R. This is the formula. So one option is the electron is coming to N1 level from N2 level. First option. Just I am showing you one option. And another option is electron is coming to one node out, but from higher energy level, that energy level may be at infinity. Because in the question you are asked longest and shortest wavelength. Means when it is coming from, it is 1, it is 2, it is 3, n is equal to 1, n is equal to 2, n is equal to 3. It is coming to 2 to 1, the energy gap is this much. And when it is coming from infinity to 1, the energy gap is huge. More the energy, least is the wavelength. So two transition. First transition is 2 to 1, least amount of energy. Low energy means highest wavelength, longest wavelength. For longest wavelength, 1 by lambda Lemon longest is equal to R into 1 by 1, and N2 is 2. So you are getting 1 by pi L longest is equal to thrice R by 4. So 1 by lambda shortest will be R. It will no doubt come to level 1, but it will come from infinity. So huge energy gap is the longest, is the shortest wavelength. So 1 minus 1 by infinity square means it is 0, means this is R. So simple, I am not doing the next part. Next part you keep it 1 and make it 2 and divide this divided by this divided by this, you are getting a ratio. I think it is 4 by 3. Lambda L by lambda S is equal to 4 by 3. This is the question asked in AIPMT or CBSE PMT in entrance exam some years ago. Very important question. Same type of questions we are getting to face within a fraction of time. I am advancing. So the question just I am going to the question. 24.6 electron volt is required to remove one electron from the neutral helium. Energy required to remove both the electron. Helium has 2 electrons. For 1 electron, energy required to remove 1 electron is 24 electron. 24.6 electron volt is required to remove first electron. You are asked to remove the another electron. So from removing both the electrons, how much energy is required? 1 electron is given. So first we know E is equal to 13.6 into Z square by N square. If it is hydrogen, we have written only this electron bond. Am I right? Electron bond. Z is equal to atomic number is equal to 1 and this is equal to 1. 1 orbit is equal to 1. 1 by 1 equal to 13.6 into 13.6 electron volt. But if there is helium or lithium like this, that's why we need to introduce Z square and N, because orbit is changing, atomic number is changing. Since it is helium, we have just written this question formula. So En is equal to minus 13.6 Z square by N square by EB. So what required here is to calculate what is Z? Z of helium. Helium is number is equal to 2. 2 means 2 square, and how much orbit is there? This is equal to 2. So how much? It is another questions from IIT or higher interest level. Options is given. Which of the following options are correct? Radius is proportional to the N square, because you know radius is N square by 4 pi square is Z square M. Am I right? So R is proportional to N square and E is proportional to 1 by S square, because 4 pi square twice pi Z k e to the power M divided by N square A square. N square is below, so E is B. So from these two relation, you are asked very simple and tricky question. Very simple questions. In which of the following relation are correct? Answer this relation is correct. Again, it is from entrance exam. Longest and shortest wavelength in Balmer series. First one, Lyman. What is Lyman? And what is Balmer? Lyman N1 is equal to 1. Balmer is equal to 2, and this is 3 dot infinity. So first, again the earlier I have mentioned longest and shortest wavelengths. What is longest and what is shortest? The less the amount of energy, more is the wavelength. Energy is inversely proportional to lambda. I have shown you already. So for longest wavelength R is equal to 1 by, here N1 is equal to 2, not 1. It is Lyman for 1. It is 2. It is 2 square minus 1 by 2. From 3 to 2, it is less amount of energy, and from less amount of energy means highest to the wavelength, and from alpha to 2, it is the huge amount of energy, minimum is the wavelength. So from first longest take from 3 to 2. So what we get here is pi by this. And what is the shortest wavelength? Shortest wavelength is related to 1 by, it will come to 2 no doubt, but it will come from alpha. Am I right? This is 0, 1 by 4. So you are getting R by 4. Now you make divide this divided by this, divided by this, you will get the answer. I needed to do, because you can do it as part. It is very simple and very easily simple mathematics needed to mention. You can do yourself. This is the question from IIT. I told you earlier that the questions are same questions are repeated very often. So So you are asked another questions, energy required for electron in the lithium 2 positive ion in the tart-Bose orbit is equal to energy. You know 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. With the help of this, we have another formula, daily. So you see the formula I have written. I think I have written the formula is, I have not written. Yes, E is equal to 13.6 z square 1 by n1 square by n2 square. E is equal to 13.6 z square 1 by n1 square minus 1 by n2 square. So electron is starting from jump from third orbit to the first orbit. So you need two orbit. Am I right? And since it is lithium, so there is atomic Z is there. Atomic number is involved. So here 13.6 and what Z lithium is equal to 3. 3 is equal to 3 square is equal to 1 by 1 square, on which energy level, orbit level is 4. And this is electron volt something I think it is like this. Energy required for excitation of electron in lithium 2 positive in third Bose orbit will be this. But the technique is you should know the formula, otherwise you can't proceed. Very important one. Again, this question is AI 2023. Very simple questions. Nitrogen and cesium, argon and oxygen. Lowest amount of ionization energy required to remove the last electron. You see, the bigger is the size, last electron is then bigger and bigger distance away from the nucleus, and smaller in the smaller of attraction towards the nucleus. So very easily we can lose the electron from this one. So cesium, due to sodium, potassium, rubidium, cesium, it's huge below of the first group, so size is bigger, last electron is far apart from the nucleus, so less amount of energy is required to release the electron, and this is the ionization energy. Amount of energy required to release the most lowly bounded electron from its gaseous state is called ionization energy. Lowly bounded electron will be in cesium since its size is big. So very simple, strike the point, nothing else. The question asked in the NEET 2022, the question is, if R1 is the radius of the second stationary orbit and R2 is the radius of fourth stationary orbit, what is the ratio between R1 and R2? What is radius? Radius Rn is equal to R0 is equal to n square by z square. Am I right? So this is equal to n square by z square. So you are concerned with R1 is equal to n square, means R1 is equal to second means n square, and R2 is equal to 4 equal to 4 square. R1 by R2 is equal to 4 by 16. I think it is 2.5, like this. This is the question asked in NEET. So simply you keep the formula. Actually Rn is equal to R1 dot, the formula, initial formula, R1 dot n square. This was the formula. So with the help of the Bohr value of Bohr radius, we can find out anybody's radius. So if it is 2, you put here 2, and 0.53 will remain constant. Am I right? So here we have considered is Bohr radius, or may not, R1 is constant, Bohr is Bohr. So R is proportional to n square. R1 in place 2 square, R2 means 4 square, 2 square by 4 square, 4 by 16, 4 by 16, 1 by 4 equal to 0.25. Yes, I am right. Am I right? So this is the question asked in NEET. This is all about the today's class. Thanks a lot for watching the class. I have left some 8 or 10 questions due to lack of time. The classes already become lengthy, and hope I am coming with this 8 or 5 solution of these classes in the next class, and which will be very important and helpful for you. Please subscribe to the class if you find the class advantageous for you. Thanks a lot for being with me.